So if there are topics that you need to really dominate on for you to clear the exam, even these 4 topics are enough for you to clear the exam. We have regression, ANOVA, hypothesis, sampling, and estimation, and sampling distributions. These are enough. So we're going to look at
Hi, Colin.
ANOVA. After I'm done with the principles of ANOVA, I will look
Hi, Colin.
at an exam question. So ANOVA stands for analysis of variance. It is a component of hypothesis testing, which looks at differences between 3 means and above. So ANOVA, like financial accounting, firstly needs you to understand how to balance it up. So balancing up the table does not require any prior information from any. You just need to understand the principle here. That ANOVA came from the principle of a farmer who had planted maize. This maize was planted in columns, which he called treatments. And after planting these grains with the same water, same fertilizer, same soil, there was a variation in the cobs, the sizes, and the health of these so-called cobs. So he called it analysis of variance. Why is it that there's a variation in the average cob size? And so these treatments, he called them K. So there was a variation between the treatments, which was SSB. So the variation that was existing in between these treatments was what? SSB. Then he also found variations within the treatments, which he called sum of square. So from here to here, that variation within, he called them the sum of square within. And then he counted the total variations, which he called the sum of square total, the total variations. So from this concept, we are just going to understand the ANOVA table. So there are 3 sources of variation between the treatment. So the sum of square, we call them SS what? So sum of square between. Then within the treatments, we call them SS what? W, sum of square within. Then we also had the sum of square total. So this is SSTO. Then there's what we call the degree of freedom. So degree of freedom is just used for reading the table. So this is K minus 1, N minus K, N minus K, then N minus 1. So N stands for the number of what? Observations. And K stands for the number of treatments or populations. So we also had what is called the mean of squares. So with the denotations here, MS, this will be mean square what? Between. And this is mean square what? Can guess? Mean of squares within, just using the first letter of that component. Then finally, we go to the F calculated, which is simply found by dividing the mean of squares within divided by the mean of squares between. So this is just your guide. You get your 15 marks from that. So if we have A, B, C, and we have 2, 4, 6, 8, and we have 3, 3, 1, 4, and we have 2, 2, 2, 4. So the columns here have been transposed. We consider columns as the titled components. Can be a row or a column, but so our treatments here are denoted by the letter K. How many treatments do we have? Our K is what? 3, because there are 3 titles, 1, 2, 3. N is the total number of elements here. we have 1, 2, 3, 1, 2, 3, 4. So our n here is 12. This is our total number of observations. Then just to calculate for you, since he will usually give you, if you're given the sum of square between as 40, and you're told that the sum of square total is 90, or I just give it 130. You're asked to balance up this Anova table. So you're going to be given how many marks to balance up? 14 marks. So let's balance it up together. So sum of square between we've been given. So let's substitute it answers in here. So let's start with what has been given. So sum of square between, what is the sum of square between 40 and sum of square within? Hasn't been given, but sum of square total is what? 130. To find the sum of square within, simply the difference. So what's the difference there? 130 minus 40, what do we get?
90.
90. Correct. Then we go to our k minus 1. Degree of freedom for the between is k minus 1. So our k, what is our k? 3. 3 minus 1, which is 2. Degree of freedom for the within is n minus k. So n is 12. 12 minus 3 is 9. So you put your 9 there. Total, we just add 2 plus 9 is 11. So as prescribed, n minus 1. So 12 minus 1 is still 11. So to find the mean of squares, we divide this answer in there, this answer in there. So 2 into 40, we get 20. 9 into 90, we get what? 10. Then finally, find the f calculated. We divide 10 into 20 to get a 2. All right, let's do a quick recap. How did we find our 90? How did we find our 90? Our 90 is called the what? The sum of square within. So to find the sum of square within, we simply subtract the sum of square total minus the sum of square what? Between. So we simply subtracted 130 minus 40. So that's how we found the 90. Simply the difference. That is our A. How did we find our B? Our B is simply what? The degree of freedom for the between, which is k minus 1. So our k is the number of treatments. So 3 minus 1 is 2. How did you find our C? Our C was the degree of freedom for the what? Within, which was n minus what? K. Our n was 12. Our k was 3 to get 9. How did you find the degree of freedom? D for the total. The degree of freedom for the total is simply n minus 1. Our n is what? 12. 12 minus 1 is 13, is 11. We simply add these two. Are we following?
Yes.
So
Yes.
E, F, G. How did we find our E? We'll start with our E is called what? Our E is called our mean of square what? Mean of square between. So mean of square between is simply found by sum of square between divided by k minus 1. So we just simply divided 40 over 20 over 2 to get 20. Then here our mean of squares within is simply sum of square within, over n minus k. So here it will be 90 over 9 to get 10. All right. That is how we found our f. So this is E and this is f. And finally, our g is called the f calculated. F calculated is now found by dividing the mean of square between over mean of square within. So here this will be 20 over 10, which is equal to 2. So Collins, I just scanned this easy in the exam. It looks too easy to be true. Well, let me take you to the exam. So this is 2022 November. So
Sorry, Mr. Collins, before we go to the exam, is this one way or two way Anova?
it is one way Anova. So two way Anova, he's never examined it. I'll teach it maybe during the physical. I don't want to dominate on what he has never brought. So one way Anova is what we're looking at. All right. So you're given a table and you're asked to complete it. So how do we find the figure here?
You subtract.
Subtract for me.
Four,
467.81 on within samples.
467 point what?
81.
81. So this is a what? Sum of square what? Within.
within,
Then how do we find the figure here?
between 3. You subtract again.
You subtract what?
You subtract 22 from the 19, you will get a 3.
A 3. Do we agree? Then how do we get the mean of squares?
We divide 3 into 490 and 19 into 467.
Correct. Ngasi, are you following?
I missed the first part of your presentation, so I was just trying to follow through how the 467.81 was found.
We just found it because the totals must add up. So if this
Yes,
is equal to that, we just subtract this minus that to get that. Even here, the totals must
yes,
add.
I've gotten that one.
So we subtract.
Also, there's just 22 minus 19.
Exactly.
Okay, follow it.
Then here it's the mean. Divide this into there, this into there.
Oh, okay.
What are we getting?
On the within samples, 24.62.
You get what? 24?
24.62 within samples.
24.62. And here,
Mm, 139,
139.75.
139.75.
75. Then here, how do we get the figure here?
You add everything.
There's no need to add it.
We subtract.
Subtract what?
Oh no,
How do we get the F calculated here?
sorry, we divide 24.62 into 139.
So this into there, correct? How do we get?
5.67. How many digits? Find 5.6.
5.67. Well, now let's answer the question. Determine the total number of observations in this ANOVA test. How many observations are there? What is our n? What is our n? How many observations are in this test? Quickly. I explained this.
9.
That's so true.
9. How did you get the 9? How did we get this?
We
added
added
19.
N minus 1 is the degree of freedom for the total. So what gives us what? 22. So if this is 22, our n is therefore 22 plus 1, which is 23. So meaning our total population is what? 23. I told you there are two ways of getting this, n minus 1 or just topping up. So the number of populations we have here is what? 23, because this was n minus 1. 2 marks for that. Then this k stands for the number of populations. So if we have 3 there, how many populations we have?
Two.
That's the correct opposite. Determine the total number of populations. If k minus 1
Three.
is equal to 3, what is k?
4.
3 plus 1, which is 4. Please don't lose marks carelessly like that. 4. Nachitanda, Pahama population gariata to ABC. The reason why we got what? We got a 3 here. The reason why we got a 3 here is because why? Because there were 3, the populations were 1, 2, 3. These are the populations. So when we subtract 1, we get a 2. E is not the number of populations. It's a k minus 1, meaning the actual population is what? It's 3. Observations, when you count them 1, 2, 3, these ones are 12 in total. But we subtract n minus 1 to get the degree of freedom for the observations. So this 11 is not the number of the observations, but since 11 minus 1, so meaning our n is what? 12. So this is the same application here. So how many observations are there? There are 23. How many populations are there? There are 4. Then complete the ANOVA table, 6 marks, which we've just completed here. So how many marks are these ones here? 10 plus what? 2. So that's about 12 marks. Anyone behind?
Mr. Collins.
Mm-hmm.
On the K, I think why I was confused is because I thought of answering saying 2 because of what I was seeing here on the source of variation. But then I think I just need guidance on that to say, because there we were looking at ABC. I think here I couldn't see any ABC, and I was kind of confused to say where would I say the 3 is coming from.
So ABC is a
So I
mean
need
of, you don't need this. This is just a guide. Sometimes they not give you this. This reflects that. So this means, okay, obviously the ABC That was ABC. If there was a 3 there, that should be an ABCD because there should have been 4. So that's what I've been showing here, the breakdown of where these figures are coming from. Our B here is because it's K minus 1. The K stands for the number of ABC. So here we have what? 3, because 3 minus 1 gave us what? So you don't need this always. It's just a guide. From this, you're only able to get 3 things. So quickly, don't let me down now. All right. I want you to help me complete the table. Suppose we have brand 1, brand 2, brand 3, brand 4, brand 5, and brand 6. And here we're given numbers here. 4, 4, 2, 3, 2, 1, 3, 3, 4, 1, 1, 5, 6, 2, 1, 7, 7, 1. And we are told that the sum of square between is 60. Okay. So the sum of square total is 100. Let's complete the Anova table. So can give me what are the 3 sources? What are the 3 sources of variations? We have what? Between?
Within
Within? And what?
and the total.
Total. So what is our between?
SSB
60. Our total? 100. Our within?
100. 40.
40. Our degree of freedom here? What is our K?
six.
What is our N? $18. What is our degree of freedom for the between?
Collins, how do you come up with the K and the N? I think I'm a bit behind there.
The K is the number of treatments, the columns 1, 2, the titles 3, 4, 5, 6. The N is the total number of observations 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18.
Okay.
Then our degree of freedom is K minus 1. What is our degree of freedom here?
54.
5.
Five.
Then here,
Oh,
5.
you've done what? Minus what?
K minus 1.
60
K
minus.
minus 1.
Then here we have what?
Okay.
N minus K. 12.
12.
Then here,
12.
17. Then here, what do we get? 12. And here,
12. 3.3.
3.33.
3.33.
And finally, what do we get there?
3.6.
0.6. Divide this in there. So how many observations do we have and how many populations are in here? From this table.
Observation is 3.
Observations is what?
It's 3.
Then populations,
19.
why are you disappointing me, you guys, today?
18.
Our N is a population, is a observation. Okay, what's the observation? And our
It's
K
18.
populations. So how many observations we have and how many populations we have?
Oh, 6
N is 18.
and 18.
18.
Which is which? N is 18,
24.
then
Yes.
populations,
K is 6.
3 is 6.
yes, that's all.
The English confused me. Observation.
No, me, I just followed what you did, like for the K minus 1. Then there on the other one, you just moved the -1 the other side, then you added.
Okay,
Sorry, Mr. Collins. Which year was that paper? Sorry.
November 2022. November 2022. I think this is May. So there are 2 papers every year. There is November and
Oh, it
this should have been May.
should be May because in
Yes,
November one there isn't that question.
yeah,
Okay.
this should be May. All right. Then let's look.
November one is somehow different. The way they brought Anova, it's somehow different and confusing.
All right, so we only have 10 minutes. Let's look at as a probability as well. So before we attempt this question, I'll teach you. This is the simplest probability. Okay, so probability of what are called discrete random variables. Probability for discrete random variables. So this is the easiest probability that you ever have. So you'll be given the value of x and the probability of x. So here we have what? 2, 4, 6. Then the probabilities, for instance, are given 0.5, 0.2, and 0.3. So you're asked to find the mean, the variance, and standard deviation, 6 marks. So this one doesn't miss, it always comes. So to find the mean, firstly, let's square the values of x. So this is what? Let's square the values of x. You can put it here if you want. So this is 4, 16, and 36. Then let's calculate, multiply the value of x times the probability, and the value of x squared times the probability. So 2 times that one, it is 1. 4 times 0.2, 0.8. And 6 times that one is 1.8. When you total up, that's called the mean. As simple as that. So the mean is when you total up this column, you're going to get what? 3.6. That's all. You get your 2 marks. Then you also multiply the squared here. 4 times 0.5, get a 2. 16 times 0.8, we get 12.8. 36 times 0.3, you get 10.8. So when you add all this, we're going to get